Okay, there's two last quick things I want to talk about when it comes to inheritance in C++. So I showed you how if you want to be able to override something and have it behave properly in polymorphism, then in the parent class you actually need to say virtual. Okay. And then it will know the proper reference. But there's something else interesting with the virtual keyword that you can do. I'm actually going to make a new class here, which is related to what you'll have in the next assignment. I'll call it Hashable. And what I'll say is the Hashable should be able to return a number from some method. Okay. But I have no idea how you're going to generate that number. And usually I recognize that with this adverb here, in Java that would mean this is an interface. We don't have interfaces in C++, but we have something close called pure virtual functions. So if I say virtual size t get hash equals 0, let's see what happens if I try to declare something of type hashable. Okay, hang on. Okay, so it says, cannot declare a variable to be type hashable because the following virtual functions are pure within hashable. So what this means is you actually, in order to use this, you must override this and provide an implementation of hashable. So for example, I can make a method called hashable int, or sorry, a class called hashable int that overrides this. This is just going to be a wrapper around int. I'll call it x. So just takes in one parameter. But then I have to define this hash function. So I'll say size t get hash. Now size t is a 64-bit unsigned integer. So what it means is it can't be negative, and it actually you can go up to much higher numbers than an int. So it's totally safe to cast an int as a size t. So I'll return size t x. So my hash function is just the int itself. It's a very simple example. So now I can certainly declare a hashable int, and now things should compile okay. Of course, I need my semicolon after the class definition. That's one thing that's different from Java. Okay, so that's all right. So that's what we call pure virtual. So this is basically like an interface in C++. If you have any methods like this, I could put in methods that I actually have definitions for. This is just some bogus method, but it doesn't matter. If I have a single method that is pure virtual, then it treats this like an interface. So if I try to say hashable again, even though I have a method in there that's not pure virtual, the fact that I have even a single one says, nope, you can't use it by itself, you're going to have to override it. Of course, I have to spell it right even to get the right error. Yep, so it says, because the following virtual functions are pure within hashable. So the get hash is a pure virtual function. Okay. So that's all right. The other thing I wanted to show you is that you can actually, I'll move this stuff up here. Like I mentioned, you can do multiple inheritance. So let's say I wanted a student to have all the properties of a person, but to also be hashable. So then all I have to do is say public person, comma, public hashable. And then it's going to tell me, okay, so if I try to say student s and initialize it this way, it's probably going to tell me that I have to implement the hash code method. Yeah, so it says, so what actually happens in C++ is if your parent class has pure virtual methods and you don't implement them, then by extension, your child class is going to become virtual as well. So unless I implement the hash code method. So what I'll do is I'll make this just return the age. That'll be the hash code for this. Maybe not the best hash code. There'll be a lot of collisions because people in college have similar ages overall. But that's fine for this example. So now that I've declared this get hash method, I should be able to compile this. And let's just check. So if I say s.printinfo, it should print the info. And if I say cout s.getHash, let's make sure that it's actually returning the age as the hash function. Oops, okay, so I've got to say person. All right, cool, so that worked. And the cool thing about this is even though Hashable is pure virtual, like an interface, I can cast things as a reference of type hashable. And now I can say h get hash. So this should work. So anyway, the point is I can have, even though I could never declare an object directly of type hashable, I can still cast it as hashable and call the virtual methods. So this is another type of polymorphism here. So the student has morphed into a hashable thing where I know I have access to the getHash method, and it correctly figures out that oh, actually, this is the one I want to call, because even though it's of type hashable, it's a student, and it's implemented that hash method. Okay. So that's really all you need to know. So it's possible to do multiple inheritance in C++. The diamond problem gets very messy, so you got to be careful that these don't have any methods that overlap. And you can do something very much like an interface. By creating classes with pure virtual methods. So that's it. Cool. So that's all we need to know about inheritance. Now we can move on to other things. And that's basically, these are like our C++ topics right here. I know I said that before, but now I really mean it. So we know how to do, all the basics. We know how to do objects, object references, pointers. Now we know how to do inheritance. We showed how to open files today in class. Now I just got to show you some more libraries that are out there, like what's, something like an array list in C++. So I'll have one more module in that. And that's it. Then we're just going to do stuff with C++. We're going to do algorithms, and that's what the rest of the course will be about. So it'll be a good primer for 371. Okay, take it easy. I will see you tomorrow.